Hello, I'm Richard Goering, and I'm speaking with Jim Ballingall, who is Vice President of Marketing at GlobalFoundries.
Hi Richard, how are you today?
Great, just great.
Thanks for coming to the conference.
Well, Jim, this is the first global technology conference. It's certainly well attended. Why did you decide to hold this conference, and what are you hoping people walk away with?
Well, we really did it just to inform the industry and our customers about the value and the different solutions we provide for the customers. It's a lot of work we've been doing, hard work over the past year or so, and a lot of things that we just wanted to inform the industry about.
Fantastic. Now, there were several presentations here on 3228 nanometer technology, specifically about high K metal gates. There are several providers of high K metal gates. What's special or unique about the GlobalFoundries approach?
Yeah, that's a good question. We're using an approach that's called the gate first approach to implementing high K metal gate. The other approach, the other well-known approach, is a gate last approach. A gate first has several advantages. It's first of all scales, not only in power and performance, but also in area. The gate last approach doesn't really scale fully, as one would expect for a full node shrink. And in fact, there's a 10 to 20% die size disadvantage for the gate last approach. So the example sometimes used for customers, if you're going to be spending $500 million, say, or $1 billion over the lifetime of your 28 nanometer products, you could save up to 15%, pick in that range of 10 to 20 as an average. That could be $150 million for $1 billion spend. That's enough to fund 2 more product lines, buy another company. So there's a tremendous amount of value that brings our customers as well as the industry.
Okay. There's been a lot of talk here about collaboration, about ecosystems. Why is that so important to GlobalFoundries, and what exactly is your Global Solutions organization?
So as we go down and march down Moore's Law to more advanced nodes, now as you noted, we talked a lot about our 32 and 28 nanometer solutions today, and also unveiled our roadmap to 22 and 20. The need for collaborating with partners becomes even greater. At DAC in June, we announced the Global Solutions ecosystem. And that involves partners in design enablement, including EDA tools, IP blocks, design services, assembly and test, and mask making. We're unique in this respect in that some of the other foundries do some of this work internally. We're truly open in the sense that we don't compete with anyone in our ecosystem, and we want to foster a very vibrant ecosystem where the goals are, business goals are mutually aligned. All right.
And speaking of collaboration, on the design side, GlobalFoundries worked with Cadence and Mentor to develop a technology called DRC+, which I understand is really a new and different approach to design for manufacturability. What's the basic idea?
It is. So what we've done with DRC+ is we've run silicon and identified specific yield patterns which detract from yield or improve yield. And so this is a pattern matching engine that actually looks at the layout and flags yield detractors, enables the engineer to fix those, the tools to fix those, so you can have a first time pass success on your silicon.
Okay. And then finally, GlobalFoundries today announced a 28 nanometer analog mixed signal design flow development kit developed in cooperation with Cadence.
That's right.
What's the significance of this announcement?
Well, we've done a lot of work in the past with Cadence and Synopsys on a digital flow for 28 nanometer. This is the first in the industry for an analog mixed signal flow. And so it's an important feature because our customers want to deal with system on chip designs, requires digital, analog mixed signal, RF, and so on. So that's really the significance of that announcement, Richard.
All right. And finally, does DRC Plus also apply to analog and mixed signal design?
Indeed it does. So the same yield detractors you may have in a digital design can also crop up in an analog mixed signal design.
Okay. Thank you, Jim.
Thank you very much, Richard, and thank you for attending the conference.